All right, we're going to try to finish most of this up. We may not get completely through, but we're going to get close. Let's see what just happened there.
Is it recording?
Yes. All right, when we have an endocrine system test, probably the week after spring break. One thing that will be on there is a diagram. You've got to be able to label where these organs are at. All these are endocrine glands. Remember that the part of the body that's actually in charge of the endocrine system is the hypothalamus. That's the part of our body in charge of what? Not only the endocrine system, but also maintaining what? Homeostasis. Keeping certain things in balance and equilibrium. We said to think of the hypothalamus and the pituitary.
That was come to the binoculars, please.
Sort of like the Emperor and Darth Vader. The hypothalamus is in charge of the whole endocrine system. But sometimes, what's the pituitary called? What's its nickname? The master gland, because it controls the other glands. The hypothalamus controls the pituitary. The pituitary controls the rest of them. So we said to think of like the Emperor, Darth Vader, and then the stormtroopers here. Okay? That's our bad, nerdy Star Wars analogy. But it works. We already know that the endocrine glands don't have ducts. There's no tubes. Hormones get directly secreted into the blood, and they go from there. Do hormones affect every cell? No. Okay? A hormone only affects the cell with the right way. The right receptor. Remember the things they do. They control things like glucose, calcium, sodium, your reproductive cycles, the menstrual cycle, milk production, and we could go on and on. Now, so far, we've talked a little bit about the pituitary. We talked about how hormones are made of either amino acids, short amino acid chains like polypeptides. They can be big proteins. If it's either one of those, the receptors for them have to be on the outside of the cell. If it's made out of a steroid, which is a lipid, ladies, come over here, please. The receptors have to be on the inside, or they can be on the inside at least. But today, we're going to very quickly just review the pituitary. Then we're going to try to move on and talk about some other important endocrine glands. The pituitary is really two glands in one. The posterior part, the anterior part. The posterior, the back part, doesn't make any hormones of its own, but it holds two hormones made by the hypothalamus and then releases those into the blood as needed. ADH. Sometimes called antidiuretic hormone, ADH. What is a diuretic? Makes you urinate. So antidiuretic hormone helps to slow down urination. When would you secrete ADH? When you're dehydrated. There was a question on your mock exam about this, right? Something about playing basketball. One of the choices at least was you would secrete ADH when you're sweating a lot, when you're not drinking enough, and that's going to help keep water in you. That's ADH's job, to keep you from dehydrating. And remember, if you see a word like osmoreceptor or osmoregulator, you're talking about regulating what? Water balance, keeping water in your body. Oxytocin is another important hormone secreted by the posterior pituitary. It causes the uterine contractions in women. It causes a woman to go into labor, give birth. Men also have it. It promotes affection and arousal in men and women both. So it's an important hormone. But the other thing we want to talk about is the anterior, front side of the pituitary. Remember, we said this is like the Darth Vader of our endocrine system. It secretes a whole category of hormones called trophic hormones. Their job is to control the other glands. That's what they do. They either turn on or turn off other glands. In addition to that, those category of hormones, they release some other things that are important too. We've already talked about growth hormone. Usually it's abbreviated out. HGH, human growth hormone. It causes your bones to get longer. It also causes fat, your body to break down fat, and it causes your body to make muscles and other proteins. Prolactin causes the breast to make milk, mammary glands to make milk. These hormones over here, this whole column, these are the tropic hormones. These are the hormones that control the other glands. This one right here is adrenal corticotropic hormone. It stimulates the adrenal gland. It turns on the adrenal gland. TSH stands for thyroid stimulating hormone. It stimulates the thyroid to make its hormone. Then you've got a category of hormones down here called the gonadotropins. These turn on the gonads, the reproductive organs. FSH, this was on your mock exam. What's the F stand for?
Follicle.
Follicle, and it's follicle stimulating hormone. What's follicle? It's the egg and the cells around it. It causes the egg to get ready to be what? Ovulated. And it causes it to grow, mature, get ready for ovulation. It also does a similar kind of thing for sperm. It causes them to get ready. LH stands for luteinizing hormone. And both of these are going to come up again in a minute when we get to the ovary. Luteinizing hormone.
Erica Kenny or Lakeisha Brown, please come to the guidance office. Ms. Brown or Ms. Kenny, please come to the guidance office. Thank you.
Luteinizing hormone causes...
Mr. Reese, please come to the guidance office. Jamie Reese, please come to the guidance office.
causes the body to make sex hormones like testosterone and estrogen. And it also triggers ovulation. We're going to see in a minute, we're going to talk about how the menstrual cycle works hormonally wise here in a few minutes. About day 13 of the menstrual cycle or so, there's a rush of LH, and that causes the woman to release eggs about day 13 of the cycle. Almost all hormones are regulated by negative feedback. And again, we've got a chain of command here. Emperor, Darth Vader, Stormtroopers. Okay? Let's say that your blood sugar is too high. Your blood sugar levels are too high. Blood sugar levels are too high. The hypothalamus senses that. Blood sugar is too high. It's like your body's thermostat. So it sends a message out to Darth Vader here, the anterior pituitary. It says, hey, blood sugar's too high. Releases a hormone, signaling. This is all about cell signaling. Signaling in the pituitary. Blood sugar's too high. You need to take care of it. So Darth Vader says, okay, blood sugar's too high. I need to take care of it. So he sends out a message to what gland? What gland in your body takes care of blood sugar for you?
Thyroid?
As I said, the pancreas. Okay? The pancreas, if your blood sugar is too high, this would be the pancreas. It releases what hormone that takes blood sugar down? Insulin. Okay? So this would be insulin coming out. As your body makes more and more insulin, the concentration of insulin goes up. And it feeds back. And it says, okay, now there's a lot of insulin. My blood sugar is going to start to drop. It also feeds back here. So the hypothalamus stops giving off his message. The pituitary stops giving off his message, which means the pancreas stops making what? Insulin. So it's a feedback thing. Make it until you get the concentration where you need it. Stop. Negative feedback. That's just showing you the pituitary, the anterior part, front part, and here's the posterior part. Notice it's directly connected to the hypothalamus. That's just some of the hormones we just talked about, showing you where they're made and how they're released, what their targets are, what do they affect. It's a guy with too much growth hormone right here, and a guy with too little. This is a woman with too much growth hormone too. After your growth plates harden, HGH doesn't make your bones get longer, it makes them get what? Thicker, wider. And you can see the effects of that over the years. She had a pituitary tumor, which means she's making this growth hormone in huge amounts her whole life. This woman's probably close to 7 feet tall. And after she stopped growing, her bones just started getting thicker and thicker and thicker. You can see it in her chin, her forehead, her cheeks. It's called acromegalia. But today we want to concentrate on glands other than the pituitary. The thyroid. When you hear thyroid, I want you to think cell respiration and metabolism. That's the main thing the thyroid does. Cell respiration and metabolism. The thyroid makes two hormones, thyroxine and triiodothyronine. Together, they're called thyroid hormone. The thyroxine and triiodothyronine together are called thyroid hormone. What they do is, first of all, they target nearly every cell in your body, which is unusual for hormones. Just about every cell in your body has receptors for thyroid hormone. How come? They all have to do cell respiration. Thyroid hormone speeds up cell respiration. It causes your body to metabolize glucose. What is cell respiration? Metabolism of glucose, right? The breakdown of glucose. So it speeds up cell respiration. Like I said, it targets almost every cell. There are conditions where you have too much thyroid hormone, and that's called hyperthyroidism. Hyper means too much, right? Above normal. People with hyperthyroidism are all shaky, jittery. They start to lose a lot of weight, real nervous acting. Sometimes it looks like their eyes are kind of bugging out. Literally, their eyes bulge. The opposite is hypothyroidism. It means too little. A lot of people who are overweight try to blame the fact that they're overweight on hypothyroidism. Because if you're overweight, it means your respiration is slower. Well, not necessarily, but this is their argument for some people who try to blame their overweightness on their thyroid, and not the fact that they probably ate too much and sat around and watched too much TV. Okay? But the deal is, if your thyroid is not putting out enough thyroxine, your metabolism is really slow, which means if you eat just a normal amount, what does your body do? Your body's like if you have hypothyroidism, your body's sort of like one of these cars that gets 60 miles to the gallon. It's very efficient. It doesn't use a whole lot of energy. So what does it do with the energy that you ate that's left over? Converts glucose into fat, and it stores it. So it could cause you to get heavy if you have too little thyroid hormone. It also is going to cause you to be really lethargic. What's lethargic mean?
Like slow.
Yeah, slow, real slow moving, lack of energy, like a slug. Sometimes hypothyroidism, there should be an O right there. Sometimes hypothyroidism is called cretinism. And there's a form of hyperthyroidism called Graves' disease. This is hyper. And in this Graves' disease, it's kind of unique. This is an autoimmune disease. Your body makes some antibodies that are very similar to TSH. Now remember, TSH is thyroid what? Stimulating hormone. It's coming from the pituitary. These antibodies look to the thyroid like TSH. So when these antibodies bind to your thyroid, what does your thyroid start doing? Pumping out thyroxine fast as it can. So you get hyperthyroidism. You get elevated metabolism, you're really nervous, you lose weight. But in addition to the hormones that control metabolism, the thyroid makes one other hormone. It's called calcitonin. And you ought to be able to look at that name and say, hey, I kind of got an idea what this does. It helps to control calcium levels in your blood. Turns out calcium levels in your blood are pretty important. Calcium is important for muscle function. It's also important for what? The development of what? Bone. So this is important stuff. It regulates your blood calcium levels and also your blood phosphate levels. Turns out these two chemicals are two of the main components of blood. Calcium, or not blood, bone. Calcium and phosphate, very important components of bone. Here's what calcitonin does. it lowers both of these. It lowers the blood levels of calcium and phosphate. And it does that in kind of a sneaky way. There are these cells in your body called osteoclasts. These are cells that break down bone. Your bones are constantly being broken down. Right now, your bones are being broken down. But at the same time they're getting broken down, what else is happening? They're getting rebuilt. They're getting remodeled so that they're always new and fresh your whole life. Osteoclasts are the cells that break them down. If you're breaking down bone, what's getting released into your blood? Calcium, phosphate. So the osteoclasts, if they're working, they should make these levels go up. But this hormone inhibits them. It stops them from working. And also, it stimulates these guys to kick into gear. Osteoblasts. These are cells that build new bone. If you're building bone, what do you have to take out of the blood? Calcium and phosphate. So by turning these on and by turning these off, both of those functions lower the calcium in the blood, they lower the phosphate levels in the blood. And that's what this hormone does. Very important in children, because that's when your bones are mostly growing, is in childhood. So the two main hormones made by the thyroid gland, thyroxine and triiodothyronine, make up thyroid hormone, speeds up glucose metabolism. Calcitonin helps to regulate calcium and phosphate levels by lowering them. There's another hormone we'll talk about in a minute that helps to raise it back up. One other thing I'll mention, this shows up occasionally. The thyroid gland is the only part of your body that needs iodine. And you can see iodine in the name here, right? Iodo. If you don't get enough iodine, what happens to your thyroid gland? It swells up. It's huge. And what do we call that? It's called a goiter. And I think I got a picture of goiter here on this next slide. There's a goiter. That's huge. We don't see that in the United States because why? Iodine is added to table salt in the United States. Iodized table salt. This is why. To avoid this. To make sure we have enough iodine. Alright, now on the back part of the thyroid gland, on the back side, the posterior side, there are 4 little bitty glands. On the 2 on the top, 2 on the bottom of the back side of the thyroid. They're called the parathyroid glands. What's para mean? Almost, near to, something like that, like a paraprofessional, a paramedic. He's almost a doctor, sort of a doctor, yeah. So this is near the thyroid, is literally what it means. These are glands near the thyroid. So there's 4 of them. They're on the back side, the posterior side. These glands make one hormone that you need to know about. And it's kind of easy to remember. It's called parathyroid hormone. So it'd be pretty easy to remember. PTH, parathyroid hormone. And notice what it does. It decreases blood phosphate levels, increases blood calcium levels. So this one kind of works in conjunction with the last hormone we talked about, calcitonin. It helps you to maintain homeostasis of calcium and phosphate. The way it does that is it stimulates the osteoclast to break down bone. So the opposite of calcitonin, right? Calcitonin it inhibited these cells. This one speeds it up. It causes your body to break down bone. It enhances absorption of calcium in your intestines. A lot of the calcium that you eat normally goes in, comes out the other end. Never goes into your blood. You don't absorb calcium very well sometimes. This makes, when the calcium is in your small intestine, which is where absorption happens, this causes the calcium to be actively transported into the blood, taken in, so you don't lose it. It also causes your kidneys to reabsorb calcium so you don't urinate it out. So it keeps calcium in your blood, raises calcium levels. One thing I'll mention here, not going to get too deep into these problems with the thyroid, but I'll mention hypoparathyroidism. A long time ago, there's cases where you get like tumors in your thyroid, and doctors would remove them. Well, they didn't realize there was something else on the back that did something different than the thyroid. So they could treat you with thyroid hormones. They knew about calcitonin and thyroxine, but they didn't know about this. And they noticed that when they removed the thyroid, you started getting all kinds of problems like tetany. What's tetany? Or tetanus. What's tetanus? It's when your muscles contract and they stay that way. They lock up. It's like a really bad muscle cramps all over your body. Also causes respiratory paralysis because what's right here? What muscle is right here? Your diaphragm. It goes into tetanus. If your diaphragm goes into tetanus, you're not going to wet. You're not going to breathe. And it eventually can lead to death. So they realized pretty quick, hey, there's something else going on here. It's not just the thyroid. We're taking out two different things. So you also, if you have your thyroid removed, you're going to have to take at least 3 different hormones. You're going to have to take the PTH, calcitonin, and thyroxine. You're going to take all 3 every so often. I don't know how often they inject them with you. But you're going to have to take those medications to be normal, to avoid death. You're going to have to have them. All right, now this is the one we want to concentrate on today, the pancreas. It's maybe the most recognized organ in the body, one of the most important organs in the body. It's both endocrine and exocrine. It's under the stomach, right underneath your stomach, right in this area. Endocrine means it makes hormones and releases them where? In the blood. Exocrine means it makes stuff and sends that stuff to a place through what? Through a tube, through a duct. And in particular, the pancreas makes almost all of what? Almost all of your digestive enzymes. Almost all of the enzymes that help you digest your food come from the pancreas. And they travel from the pancreas to where? Through small intestine, through a duct. It's called the pancreatic duct. So that's pretty important. The exocrine parts of the pancreas are called acinar cells. So these are the parts that make the enzymes. The endocrine parts are called the islets of Langerhans. And for some reason, that's a word they like to ask about on AP exams. It's islets of Langerhans. That's the endocrine parts of the pancreas. The reason it's called that is if this is the pancreas is sort of shaped like this. Most of the pancreas is exocrine. Most of the pancreas is made of those acinar cells. But every now and then, there's a patch. You know, like so. So you can see this might sort of look like an ocean. And these look like little islands. Islets means islands. Okay? And Langerhans is the guy who figured out what was going on. So it's the islets, the islands of Langerhans.
What's island is?
I don't know. I don't have any idea. It's been quite a while ago, but I don't know. I think he's probably was a French guy. That's where the name comes from. Here's the main thing you need to know about the pancreas in terms of endocrine function. In terms of endocrine function, it makes 2 main hormones, glucagon and insulin. Those 2 hormones help to control your blood sugar levels, your blood glucose levels. They're opposites. Glucagon raises blood sugar, insulin lowers it. That's important to know. Don't confuse glucagon with one other thing that sounds very similar. Glycogen. Okay? Don't confuse those 2. Glycogen is a polysaccharide that we use to store glucose, right, in our liver and in our muscles. Glucagon is a hormone that helps to raise blood glucose levels. They're different. Don't confuse them. Here's what glucagon does. Glucagon is made by cells called alpha cells in the islets of Langerhans. And like we said, it raises blood sugar levels. It does that in a number of ways. One of the ways it does it is by causing the liver to break down glycogen. Think about what I just said. What did I just say glycogen is? It's a polysaccharide made of what monomers? Glucose. So if you break down a polysaccharide made of glucose, what do you get? You get glucose, okay? Glucose in the blood. Glucose is released into the blood. This word looks really confusing, gluconeogenesis. But break it down. What have we said over and over again genesis means? Creation. What's neo mean? You've heard that word neo before. New. And glucose. So the creation of new glucose. Your body actually makes glucose. That increases blood sugar levels. And then another thing it can cause to happen. It can cause cells in your body to release glucose out into the blood. Regardless, all three of these things are all having what net effect? Glucose up. Glucose in the blood goes up. That's what all those things do. They cause glucose levels in the blood to go up. Insulin, on the other hand, is the opposite. Insulin is made by cells called beta cells in the islets of Langerhans, and they lower blood sugar levels. They do that in a couple of ways. They cause glucose to be oxidized. What do we know oxidation is? Breaking down, because we're taking away what? What are we taking away when we oxidize things? So three things. Electrons, H pluses, and most important maybe, energy. Okay? Electrons, H pluses, and energy. So we're breaking it down. Obviously that's going to lower blood glucose. It also causes your body to make glycogen. Well, what's glycogen made out of? Glucose. So if you make glycogen, you have to take glucose out of where? The blood, which is what we're trying to do. Trying to take it out of the blood. Also, it causes glucose to get converted to fat. And it causes glucose to get used for protein synthesis. All of these things cause glucose levels to drop. All of these things cause glucose levels to rise. So these two things work together, sort of like a seesaw, to help maintain the balance of blood sugar, your glucose in your blood. I'm going to come back to this slide in a minute. I want to show you a graphic here, though. Here's my little seesaw analogy. Here's homeostasis. Your blood sugar level should be between 75 and 110 milligrams of glucose for every 100 milliliters of fluid. Let's say here, though, that your blood sugar levels get a little bit too low. Get a little bit too low, so we need to raise up the bar a little bit. And the way we're going to raise it up is we're going to secrete glucagon. So maybe it's been a while since you ate. Your blood sugar levels start to drop. If they drop too much, you're going to get really lethargic and tired, and you may pass out if your blood sugar levels get too low. Your body doesn't want that to happen, so in between eating, it releases glucagon. That glucagon goes out to the liver, and it causes the liver to break down glycogen and release glucose. It also goes out to the fat, and it causes the fat to be broken down and used to make new glucose. Releases glucose into the blood. Glucose levels go up.
Which diet that doesn't do that?
Yeah, it can. Sure can. I passed out because my blood sugar got too low before. Especially, well, I used to play basketball like crazy, 5 or 6 hours a day sometimes when I was in college. And yeah, I mean, I just kind of gym rat for a long time. And we played at night, we played late at night, and we played 4 or 5 hours one night, and from like 5 to 10 or 11, didn't eat dinner, we just played. We got water. Went to bed the next morning, woke up too late to get to class. So threw on some clothes, ran out, no time to eat. I was in the anatomy lab in college. I woke up on the floor, okay? Literally, I woke up on the floor and the professor was shaking You okay? You okay? They gave me some peanut butter, and I was good in 5 minutes, ready to go back to class. But I learned a lesson. If you're going to exercise crazy amounts like that, you got to eat. Okay? You got to eat. They actually cause you to go into a coma, but you may not wake up from. So this is important stuff. Okay, very important stuff. So if your blood sugar levels are too high, maybe you just ate, maybe you just drank a Coke, you loaded your blood up with blood sugar, with glucose. Your pancreas says, okay, too high, let's release some insulin. The insulin goes out to the liver and it says, take out some of that glucose out of the blood, use it to make glycogen, store it for later. So it stores glucose as glycogen in your liver, and what's that right there? It's supposed to be your muscles. Okay? So glycogen gets stored in your liver and your muscles, and it also turns some of that glucose to fat. So it makes fat. Together, these two things maintain our level, our homeostasis. Again, know what insulin does. Lowers blood sugar. Know how it does it. Causes your body to make glycogen. It causes your muscles to make glycogen. It causes your adipose tissue to make fat. Adipose is just another name for fat tissue. Had a friend in high school who was a little heavy, and that was his nickname. Adipose. We call him that all the time. Yeah. Well, we didn't just want to call it fat, so it was an inside joke, He knew what it meant, but most people didn't know what it meant. So yeah, it was between us. Okay? It was between us. Just between friends. Also know that glucagon raises blood sugar, and it does it by causing your body to use fat to make sugar, and it also causes your body to break down glycogen in the liver, release that glucose into the blood. All right, we'll end up with the gonads here. The gonads are the ovaries and the testes, obviously. They make steroids. Ovaries produce estrogen and progesterone. Those are the two main hormones made by the ovaries, estrogen and progesterone. Estrogen stimulates the maturation of the sex organs, the ovaries, and it causes the secondary sex characteristics. What are we talking about? Secondary sex characteristics. What do we mean? We're talking about the things that happen to a woman's body at puberty. Curviness, breast development, body hair, that kind of stuff. Okay? Things that happen at puberty. Okay? Just know that secondary sex characteristics are those changes that occur when a girl hits puberty. Also, they're involved in the menstrual cycle, in bone health, heart health, general health in general. What happens to a woman after she hits menopause and she stops making very much estrogen? What happens to you ladies' bones? Start falling apart. Osteoporosis. Okay? What happens to a woman's heart after menopause? After menopause age, you ladies become more likely to have a heart attack than us guys. Before, we are way more likely than you are, right? But after you're more likely to have a heart attack than we are. Estrogen protects you. And when you stop making it, that protection is lost. Well, no, that was the idea. Tia brought up a good point. Just a few years back, all the rage in the medical community was after menopause, let's just start giving women injections of estrogen. And that sounded like a really good idea, right? Should prevent osteoporosis and heart health. Well, they found out it didn't stop osteoporosis. But what started happening? These women started having more heart attacks than normal, and they started developing what? Reproductive cancers. Way more than normal people. Right? And they're really not sure why exactly. So that's kind of been discontinued. It's very rare now for a doctor to prescribe estrogen to a woman after menopause. Very rare. The body just seems to be fighting that. It doesn't It doesn't quite work the way doctors thought it was going to work. Progesterone is the other main hormone that a lot of you may not have ever heard of before. It's really important in the menstrual cycle and also in just reproduction in general. We're going to mention testosterone here, and this is going to be about the only time. We're going to talk a lot about the female cycle in a second, but for testosterone, maturation of the sex organs, secondary sex characteristics, things like muscle development, the voice becoming deeper, facial hair growth, those kinds of things. Causes the sex drive, also causes sperm production. But what we want to concentrate on now for the next few minutes is this, okay? We want to talk about the different hormones that control the menstrual cycle. The menstrual cycle is all about, mostly, what part of a woman's body? What's coming out when the woman is bleeding? The lining of the uterus, which is called the endometrium. Endometrium. That is a term today you need to leave here knowing. It's the lining of the uterus, the inner lining of the uterus, the endometrium. All right, so here's the picture of the endometrium. Another key thing you need to know. Day 1 of the menstrual cycle. What is day 1 of the menstrual cycle? Day 1. Day 1 is when the bleeding starts. Okay? Day 1. Okay? So here's day 1. Join me here. We don't have a lot of time here, so we need to finish this game. Here's day 1. Day 1, what starts to happen? The endometrium starts to basically fall apart and come out. Okay? And that's the bleeding. The endometrium is sloughing off, and you're losing tissue and blood. This is coming out. See, it goes from being thick down to being thin over here. A lot of it's sloughed away. As that's happening, notice there's 4 main hormones that control your cycle. Estradiol is another name for estrogen. So the blue line is estrogen. The green line is LH, luteinizing hormone. The red line is FSH, follicle stimulating hormone. And the black line is progesterone. 4 hormones control your menstrual cycle. Notice up here we've got the egg, the follicle. Day 1 of the cycle, it's a little bitty thing. It's sitting in the ovary. As we go through the cycle, notice that estrogen levels are pretty high. FSH levels stay pretty much constant until about day 13 or so of the cycle. Those 2 hormones together, FSH and estrogen, are causing the follicle to mature. It's growing, it's swelling, getting bigger and bigger. As the cycle goes, it's getting bigger and bigger and bigger. Around day 13 of the cycle, notice that we get a peak of estrogen. We also get a peak of LH and a peak of FSH. All right there in the middle of the cycle. The FSH, its job is to cause the egg to mature. Follicle stimulating hormone, right? About day 13 or so, it's mature. It's ready to go. This is the egg inside. This other stuff's the follicle. LH, it spikes about day 13 or day 14 of the cycle. Its job is to trigger what? What do we say LH triggers? Ovulation. Notice here the egg pops out. That's the egg right there. That's ovulation. The egg pops out of the ovary, headed to where? The fallopian tube. And then to where? Ovary to fallopian tube to uterus. Okay? I'll be still for just a second. Let's finish this up. After it pops out, after that egg is ovulated, the follicle, this part of the follicle is left behind in the ovary, and from there on out, it's called the corpus luteum. That becomes an endocrine gland. That starts making progesterone. So the corpus luteum makes the progesterone. Notice that goes up after ovulation. That hormone causes this to happen. What's happening right there? The endometrium is getting what? Thicker, and all these little lines are blood vessels. So it's becoming vascularized. Thick, and a lot of blood vessels. And it's getting ready for what? The implantation of a baby. Okay, that's what it's getting ready for. Okay? It's getting ready for a baby to stick in here somewhere. Implantation. Well, if that doesn't happen, the corpus luteum degenerates and dies, which means what happens to progesterone levels? They drop. And when they drop, what happens to the lining of the endometrium? Starts to slough off and die. Okay? If a baby is implanted, this stays around, which means what happens to the lining of, well, what happens to progesterone levels stay high, which means this stays nice and thick and ready to go. We'll talk more about this later. That's the basics. The place to stop. So it's important for you to know that epinephrine is another name for adrenaline. I'm going to mention one other quick set of endocrine glands. Not going to say a lot about them today. I've mentioned these before in these talks. The pineal gland is located in the brain, in the third ventricle, the third space in your brain, and it releases a hormone called melatonin. Don't confuse that with melanin. Melanin is your skin pigment. It's responsible for brown pigmentation in your skin. Melatonin is a hormone, and what we think its function is it helps to influence your sleep-wake cycle, or what's sometimes called your circadian rhythms. When you're awake, when you're asleep, when you're active, when you're not. It's sort of your body's built-in biological clock. The other gland I want to mention is the thymus gland, which is just below your sternum in your chest. As you get older, it tends to diminish in size, it shrinks. The hormones from the thymus gland seem to cause your T cells, your T lymphocytes, to mature and to get ready to fight disease. Things like your cytotoxic T cells. Summarize the endocrine system in this way. The endocrine system is a series of ductless glands. They secrete hormones into the blood, directly into the bloodstream. Those travel out and affect only cells with the right receptors, what we call target cells. They're cell signals, hormones are. And those cell signals tend to either turn off or turn on specific chemical processes in your cells, specific chemical reactions. The hypothalamus is like the emperor of your endocrine system. It's the controlling factor. It's monitoring concentrations of things like blood sugar and sodium in your blood. It sends out signals if those get away from homeostasis to your pituitary. We said your pituitary is like the Darth Vader of your endocrine system. If there's a problem, it will send out information to the other glands in your body, and then they will send out hormones to correct the problem and get things back into homeostasis. So that's the endocrine system. Hope that helped.